Hey guys, I'm Rayhane, and in this tutorial, you will learn everything that you need to know about coroutine in Kotlin. Let's start. Guys, in this video, I will cover basic coroutine concept, and in the end, you will master in the coroutine topic. Okay, I will try to cover a below topic and answer this question. What exactly are coroutines? Why use coroutines? How can we create them? And also, what are the suspending function? Also, we will get familiar with coroutine builders, dispatchers, coroutine scope, coroutine context, coroutine cancellation, exception handling, and also job in coroutine. So, guys, please follow this video step by step along with me. Also, the source code has been uploaded to GitHub, and I put the link on the description. If you are new in the channel, please subscribe my channel and give this video thumbs up. So let's start to understand the basic of coroutines and what coroutine in Kotlin and how we can create and use in our application. To understand what coroutines are, you first need to know how exactly your application works. When the user launches it. When the user launches your application, a default thread is created. And this thread is known as the main thread. Now, this main thread is life of your application. Let me show you the main thread with help of this green arrow. And on this main thread, we perform a small operation such as UI interaction, click on the button, mathematical operation, a small logic operation. So, we use the main thread to compute a small operation. And now, what about the operation that take a long time and are heavy? Operation, for example, that require the use internet, upload or download a file, loading and displaying an image from server, or running some heavy database query. Well, if you run this heavy operation on the same main thread, your main thread will be blocked, and then your application will freeze. It will get hung if your main thread remains blocked for a longer time, for example, 5 seconds. Eventually, your application will shut down with a crash message. So, running such a heavy operation in the main thread is a really bad solution. Our solution to this issue is that we can create a worker thread or a background thread. And on this worker thread, which is also known as the background thread, we can run heavy operation. We can create a thread for some perform a network operation. We can create another for background thread to download or upload a file. We can have another one for load image from server or perform some heavy operation. So, in general, you always create a new thread to perform some operation without affecting your main thread. It seems like a good solution, but no, there is a limit to how many background threads you can create at a time, because creating threads for each operation really is bad idea. Because if you create more and more threads, then there will be a time when your device will run out of memory. And once again, your app will shut down. Coroutine here can be solution. When you use Coroutine, you don't have to create so many threads for each operation. You can have just one background thread and you can launch Coroutine on this thread, such as launching a coroutine to perform some network operation. Launch another one for some background thread to perform upload or download the file. Launch more for loading an image from a server. We can also have multiple coroutine perform a different task. You can perform so many heavy tasks with memory consumption of one background thread. And this is what a coroutine does. And there is a good question, why use coroutine? Android developers have many async tools available today. Async tasks, jobs, threads, and RxJava. These are just a few examples. You already have a lot of tools. So why would you need to learn another one? If you have worked with Rx, then you know it takes a lot of efforts to get to know it well enough to be able to use it safely. Async tasks and threads are easily capable of causing lags and extra memory usage. Finally, using all these APIs can introduce a ton of code since they use callbacks. Also, adding more callbacks can make your code unreadable. Once you try Kotlin Coroutine, you will realize they are not just another tools. This is a totally new way. Okay, let me show you how we can work with coroutine in code. Guys, here I use IntelliJ IDEA to show some basic code for coroutine. So please install this software on your PC and create a new project with this setting language Kotlin, build system Gradle, and also here Gradle DSL. Please choose Kotlin. Okay, let's create. Okay guys, after creating, please add this dependency in your build Gradle file here, and then sync it your project. Okay, let's create our first Kotlin file here, and then put the name, for example, sample1. Okay, we don't need this one, and we should put this code here. Yes, so far so good. Basically, this main function runs on the main thread. Let me put some code here and show you the name of our thread. Okay, here I want to put a code for sync the thread name. Yes, current thread and name. I can put some code here. Oh, sorry. Thread has a name, something like that, and let me run it. Okay, as a result, you can see the thread name is main. And now let me create a background thread that is also known as a worker thread. So let me create that. Just cut it. Well, thread. Here I want to use lambda expression is gonna to create new thread for us. And inside this thread, I want to paste this code and change some text here. Has it run? Yes. And here I want to start this thread here, and again let me run it. Okay, here as a result you can see the thread here, a worker thread. Okay, and now let's create our first coroutine. Okay. And let me run it and then explain all the things. Here you can see first hello, printout, and then word. Don't worry guys, I will explain all these code in great details later, but for now I just want to give you a quick review. Okay, about run blocking. Run blocking is coroutine builders that bridge between known coroutine word of a regular function main and the code with coroutine inside of run blocking. And the other thing it's new is launch. Launch also is a coroutine builder. It launches a new coroutine concurrently with the rest of code, which continue to work independently. That's why hello was printed first. And about another new things in the code, delay. Delay is a special suspending function. It suspends the coroutine for a specific time. Suspending a coroutine does not block the underlying thread, but allows other coroutine to run and use the underlying thread of their code. Okay, great, guys. Previous, I said a word. Maybe that's make a question for you about a suspending function. What are suspending functions? A suspend modifier was added to coroutine code. Doing this informs the compiler that this function needs to be executed inside the coroutine. Suspend functions can be viewed as a normal function, that is sometimes suspend and resumed. The suspending function are only allowed to be called from a coroutine or from another suspending function. In short, they cannot be called from outside a coroutine. Okay, so far so good. The next topic that I want to tell you about coroutine builders. So let me create another file. Delete this. Okay. Coroutine builders are basically a few functions such as launch, run blocking, async. And from our sample, we have already got a basic concept about them. So here we will dive deeper and explore them in detail. There is a first question. What are coroutine builders? Coroutine builders are a method for creating coroutine. As the name points, since they are not suspending themselves, they can be called non-suspending code or any other piece of code. They act as a link between the suspending and non-suspending parts of our code. We have three types of coroutine builder. Okay, here you can see we have three types of coroutine builders: run blocking, launch, async. A coroutine can be created in many different ways, but these are the most important. Let me tell you about run blocking. When a coroutine is constructed with run blocking, the current thread is blocked until all tasks in the coroutine have been completed. The main goal of run blocking is to prevent blocking of the main thread. So why do we require it? The answer is to test suspending routines. We typically use run blocking. During the test execution, it is important to avoid completing the test while performing intensive work and the test suspend routine. Let me show you run blocking, how it's work in a code. Here, let me comment this line. Okay, and here I can start coding. Okay. Yes. Here I want to use a delay for 1 second. Okay. And I want to print something. I can print. Yes. And I want to have this part. Yes. And the end of this run blocking's functions, I want to print hello. Okay, let me run the code. Okay, as a result, you can see each word's print with a delay. And then in the end of run blocking, they execute my code in the main thread. Okay, and about unit test. How we can use run blocking in the unit test. Here, I just want to show you a simple sample usage. We can assume we have this class for test. And inside this class, I want to perform a test. And we can have something like that. And we can use run blocking in our test like this. Okay, the other thing that I want to tell you about the launch. As I said to you, launch is a coroutine builder that creates a new coroutine without returning any result. It can also start a coroutine in the background. The launch function is an extension function on the Coroutine Scope interface. This is part of an important mechanism called structured concurrency, whose purpose is to build a relationship between the parent coroutine and the child coroutine. Let me show you in code. Okay, here I want to create another main function. Okay, and inside in my main body, I want to add some code. Here, call launch, and again, can copy this code and paste it here. Just let me remove the comment button, okay, and clear the code. And again, I want to repeat this part 2 times. Okay, and the end, I want to print okay, and here I want to put a thread asleep for a 2 second, for example. Okay, let's run it and see what happened. Okay, as you can see, here we are a different result that we when run the run blocking. Why? If you remember, as I said before, run blocking block the main thread. So first run the own code here and then run the main thread code. And here, as I said about launch doesn't block any thread. So first of all, print hello, and after 2 seconds, print the word. Great, guys. The other things here that I need to say about async. If I want to be honest, the best feature of Kotlin's coroutine builders is async. Async is a coroutine builder similar to launch, but it returns some value to the caller. Using the async method, you can perform an asynchronous task that returns a value. In Kotlin, this is called a deferred value. When a wait is applied to get the value of the delivered deferred object, the async builder is suspended. Async will pause the currently running coroutine until the outcome has been determined. The coroutine continues to run as soon as the result is returned. Okay, let me show you in the code. I want to show you how to use await to retrieve data from coroutine with async. Okay. Guys, I uploaded all these source code in my GitHub and put the link on the description. You can check it. Here I want to add run blocking like that, yes. And inside these result Yes, it's good. And yes, this one. And here I want to pass int. And here I should call my async. Okay. Here I want to put some delay. For example, just 1 second. And then pass that number here that I want to get. Okay. And here there is 2 ways to get this differ value. The first way, let me create something like that. Result, yes, from int, and here I can call my variable and call await, and then pass it into my, for example, print function. And the next way I can use directly into my print code, something like that. Let me run the function. Okay, the same result, because here I pass the number, and then here and here print the result of my this async coroutine builder. Great. Guys, the other things here I want to tell you is about dispatcher. Here, let me create a new file. Great. What is dispatcher and why we use this? You can specify the coroutine contents when you start a coroutine. The coroutine context has a coroutine dispatcher that chooses the thread or threads that will be used by the related coroutine to execute. The dispatcher for the new coroutine and other contents element can be explicitly specified using the optional Coroutine Context parameter, which is accepted by all coroutine builder, including launch and async. There are basically 4 types of dispatcher. Here you can see dispatcher main, dispatcher default, dispatcher IO, dispatcher unconfirmed. About the first one, dispatcher main. A coroutine dispatcher that is confined to the main thread operation with UI object. Let me show you in the code. Okay. Create a main function here. And I want to use run blocking. And here pass a unit. Yes, and inside the run blocking, I want to launch. In the launch, we normally call dispatcher here, but when you don't put anything, that means you want to use dispatcher main. Okay, and let me print. Okay. Current thread is, and here thread dot current thread dot name. Let me run the function and see the result. Yes, here you can see the launch without dispatchers. That means we work on the main. Okay, the next one, dispatcher default. The default coroutine dispatcher that is used by all standards builders like launch async, and so on. Let me show you in code, and also let me copy and paste my code for saving time. Okay, here guys, need import dispatcher, and here you can see I use dispatcher default. And let's see what happened here about the name of the thread. So let me run it. Okay, here you can see default dispatcher. Great guys. The next one is I/O. The coroutine dispatcher is designed for offloading, blocking I/O task to shared pool of threads. Okay, let me show you what happened when we use I/O. Okay, for a dispatcher part. Okay, and again here, and run our function. Okay, here you can see again show us the default dispatcher, and it's okay and it's correct. The last one, dispatcher unconfined. A coroutine dispatcher that is not confined to any specific thread. It executes the initial continuation of the coroutine in the current call frame and lets the coroutine resume in whatever thread that is used by the corresponding suspending function without mandating any specific thread policy. Okay, let me show you what happened when I use dispatcher unconfined. Okay, here, let me paste it and run it. Okay, you can see, as we expected, here there is a main. Okay, and guys, if you remember when I run this part of code about dispatcher default and also dispatcher I/O, we got the same result. Why? What is difference between I/O and default dispatcher? The main difference between these two is default dispatcher performed for operation you want to offload from the main thread, like CPU intensive operation. But I/O dispatcher preferred for heavy I/O operation like read, write files, uploading, or decrypting or encrypting files. Dispatcher.io has a unique property of elasticity, which means its pool is not limited to a 64, as we can decide to limit it to as many threads as we want. Okay, great. So far, so good. If you have any question, please don't hesitate, ask me in the comments. Okay guys, the next part that I want to show you and tell you about Coroutine Scope. Let me back into Android Studio and show the rest of the tutorial on the Android Studio. Okay guys, here as always I have a new project in the Android Studio when I want to continue our video about Coroutine, and here I want to talk about Coroutine Scope. Scopes in Kotlin coroutines are very useful because we need to cancel the background task as soon as the activity is destroyed. Here we will learn how to use scope to handle this type of situation. Assuming that our activity is the scope, The background task should get cancelled as soon as the activity is destroyed. In the activity, we need implement Coroutine Scope. Here, guys, we can add Coroutine Scope. And then here we can put some code. Override Coroutine Contents. And here, as you can see, there is automatic code, but here need complete from us. I should delete this one, and here I should put our dispatcher. For example, here I want to use main dispatcher. When we need the global scope, which is our application scope, actually not the activity scope, we can use the global scope like this. Yes, here, as you can see, the launch. And for example, here we have some methods for fetching user data like this. Just here, let me call dispatcher. Yes, for example, here I can call another dispatcher, and inside this async method, I can call my method for example, fetch user data. Let's just create it for avoiding the error. Yes, something like that. And I can also have it for my another user. Guys, this code just example. I just want to give you a concept of the Coroutine Scope, for example, Coroutine Scope, and how we can use it in our code, in real code. And here we have another function for my first user. Yes. Okay, here, even if the activity gets destroyed, the fetch user function will continue running as we have used the global scope. Okay, the other things that I used here is Coroutine Context. What is this? Coroutine contexts are always executed in some context represented by a value of the Coroutine context type, defining Kotlin standard library. The Coroutine context is a set of various elements. The main elements are the job of the coroutine, which we have seen before, and its dispatcher, which is covered in this section. The coroutine context includes a coroutine dispatcher that determines what thread or threads the corresponding coroutine uses for its execution. The coroutine dispatcher can confine a coroutine execution to a specific thread, dispatch it to a thread pool, or let it run unconfined. All coroutine builders like launch and async accept an optional coroutine concept parameter. that can be used to explicitly specify the dispatcher for the new coroutine and other contents elements. Okay, here let me try some code and show you some contents of the coroutine. Okay, let me delete this part and also this part. Guys, you can find the source of code, this project, and under this video on the description of the video. That name is Coroutine Intermediate, and I put the link in the description and you can check it. Here I can write my code. First of all, I want to call run blocking. Yes, and inside the code, first I want to call launch, and here put it some look. Just let me copy and paste it here for saving time. Just need import this one, and here we can create a tag. Okay, like that. And here I can put the name of the tag, coroutine context. Okay, great. And inside the run blocking, I want to add another launch with a different dispatcher and put another one, yes, with another dispatcher. Okay, here, great. I guess need a block here, yeah. Okay, I guess need this one, yeah, here, and clean the code. Here, let me run the application and see the result in the logcat. Okay guys, here you can see the result of our code. Okay, the next thing that I want to tell you about coroutine cancellation. So let me delete all of the code. Okay, when launching multiple coroutine, keeping track of them or canceling each individually can be a pain. Rather, we can rely on canceling the entire scope coroutine or launch into as this will cancel all the child coroutine created. For example, let me copy some code that I have here. Okay, here, for example, we have a scope defined for this layer of our app, like that, and we want cancel whole the scope. And here, as you can see, we can cancel whole the scope. That means canceling the scope cancel its children. Cancel the job. But sometimes you might need to cancel only one coroutine, maybe as a reaction to user input. For example, you want to cancel job 1. Cancel ensures that only the specific coroutine get cancelled and all other siblings are not affected. For this approach, we just need, instead of cancel scope, call cancel job. And that means a cancelled child does not affect other sibling. Okay, the other thing that I want to tell you about exception handling. That is really important when you're working with a coroutine. Exception handling is another important topic, and really we must learn this. When using launch, one way is to use try catch block. Let me show you with the code. Okay, here we'll assume we have a code like that for fetching the user data. For handling exception, we can use try and catch. But there is another way to use these exception, and in my idea, it's the better way and the professional way. Here we can create a variable handler here, a variable like this, and let me import, yes, here as you can see, and then call it in our launch method here like this. Okay, here as you can see, if there is an exception in fetch user, it will be handled by handler which we have attached. Okay guys, the other topic, and I guess the last topic that I want to tell you in this tutorial about job. What is job and why we need it and why we use it? Whenever a new coroutine is launched, it will return a job. The job which is returned can be used in many places, like it can be used to wait for the coroutine to do some work, or it can be used to cancel the coroutine. The job can be used to call many functionalities, like the join method, which is used to wait for the coroutine, and the cancel method, which is used to cancel the execution of the coroutine. Let me show you in the code. First, let me delete this part and also this part. Okay, here I want to create a job. So job 1, for example, and as I said before, the job can return a coroutine scope. So here I want to create launch, and here again call coroutine scope, and inside this I want to have another job too, and here I want to have another job, for example, for do something. It's just example, and I wanted to give you a concept of job and how it's work. Okay, here with this part, you can define a job, you can create a job, and also there is another command you can invoke and complete. I mean, when is job finished, you can do something. How? With this code. Here you can see we can put, for example, a log here, and also let me you can have instead of this function you can put, yeah, here, and let me delete this part and run our application and see what happened. Okay guys, here you can see our logs. The job started and the job 2 started, and the last code about job finished. Okay, great. A coroutine can be controlled through the subfunction that are available on the job interface. As I said before, like join, like cancel. What is the join method? Join function is a suspending function. It can be called from a coroutine or from within another suspending function. Job blocks all the threads until the coroutine in which it is written or has contents finished its work. When the coroutine finish, lines after the join function will be executed. Let's take an example that show you how it's working, a join function. Okay, again, for saving time, let me copy and paste my code here, and let me run the application, and here we can see the result of our code. It can be seen that the long statement is not allowed to execute until that coroutine that is running finished its work, and it happened possibly only due to the join method. Okay, and the other hand, we have another method, cancel method. Cancel method is used to cancel the coroutine without waiting for it to finish its work. It can be said that is just opposite to that of the join method, in the sense that join method wait for the coroutine to finish its whole work and block all other threads. The cancel method, when in contrast, kills the coroutine, for example, stops coroutine. Let's take an example that show the working of cancel function. Okay, here I have some code and put it there. Okay, and let me run the application and see what happened in the result. This tag is not executed anymore. Why? Because we are delaying half a second and then we are saying to jump on cancel it. Then we are canceling it. So because of that, we got this result. Here, this tutorial is done, and I hope you get a useful information from this video. Again, if you have any question, please ask me, don't hesitate. And I will try to create some video about using coroutine in real projects with maybe a room or retrofit, and I will post it on the channel. Thank you guys for watching my video. Please, if you are new, subscribe my channel, like my video, and also leave me your comment. Have a nice day.